Hi, this is Mrs. Finney. Today I'm going to talk to you about lines and angles and how they relate to each other in space. Then we're going to go on a little bit and talk about parallel lines and the angles they create when they are cut by a transversal. So let's begin with parallel lines. We learned parallel lines last semester, and we know that they are in the same plane. They are always equidistant apart, and they will never intersect. So AE and BF are in the same plane, they are equidistant apart, and they will never intersect. BF and CG are in the same plane, they are equidistant apart, and they will never intersect. The next type of line we have is called a skew line. A skew line is not coplanar, and it does not intersect. It is not coplanar. So AB and CG are not in the same plane, and they will never intersect. We're not just going to talk about lines, we're also going to talk about planes. You can have a parallel plane. Think of a Rubik's Cube or a dice, and you will see that the top plane, ABDC, is parallel to HEFG. In the same respect, this plane on the side would be parallel to this plane. The front plane would be parallel to the back plane. Now we're going to talk about parallel lines that are cut by a transversal. A transversal is a line that intersects two or more lines in the same plane and intersects them at very specific points. And we're going to talk about the angles that these points create when the lines intersect. We also have to talk about the interior and the exterior. This is important because our angles will be interior angles or exterior angles. And the transversal creates all of these different types of angles. The first angle that we're going to talk about is going to be alternate interior angles. Think about what the word alternate means to you. If I'm on the alternate side of the street, I'm on the opposite side of the street. So our angles are going to be in the interior, but they're also going to be opposite each other. So angle 3 and angle 5 are alternate interior angles, and angle 4 and angle 6 are alternate interior angles. Something is special about these angles. They are congruent. So angle 4 and angle 6 equal each other. Angle 3 and angle 5 equal each other. This is the sign that we use for congruent. It means equal in geometry. The second type of angles that we're going to talk about are same side interior. Same side interior says that they are going to be on the same side of the transversal. Same side, and they're going to be interior. Same side, interior. So I can say that angle 4 and angle 3, I meant angle 5, are on the same side, so they are same side interior, and angle 3 and angle 6. These also have very special relationships. These two equal 180 degrees, and these two equal 180 degrees. They are the only angles that together equal 180. The rest of the angles will be congruent. The next type of angle are called corresponding angles. Corresponding angles are also on the same side of the transversal, but they are in as well corresponding positions. So angle 1 and angle 5 are in the same location with respect to the transversal and the two lines. We can say that angle 1 corresponds to angle 5, and they will be congruent. We can also say that angle 2 and angle 6 are corresponding angles. We can say that angle 8 and angle 4 are corresponding angles. And last but not least, angle 3 and angle 7 are corresponding angles. So they are in the same location with respect to the parallel lines and on the same side of the transversal. So you have seen 4 different types of angles that are created by two parallel lines cut by a transversal. We have a couple more angle pairs that we'll be talking about in class tomorrow. So hopefully bring your notes with you with questions and we can get right to work. Bye.